Hello everyone. In this video, we are going to introduce the topic of Object-Oriented Programming, or OOP, which is an advanced programming topic, and it has gained quite a bit of popularity in all sorts of different programming languages because of some specific benefits it has. We're going to talk about it. Now, the main reason I'm talking about it here is some of the stuff in MATLAB, you need to know OOP before you can use them effectively. And one of the topics that I want to talk about in my next video is the MATLAB app designer. Okay, so if you go under apps and then click on design app, it brings the environment for the app designer. And here is where you can create apps that you can compile into standalone apps, and you can even deploy them on your cell phones, on other computers that do not have MATLAB, and so on. Okay, so they're going to be executable files. And here you'll see when we go through it, the items are written as objects. Okay. So before we can work with this and understand it, since this is also an important topic, although advanced topic, I said let me at least introduce a little bit of that. So in this video, I'm not going to talk about entire object-oriented programming, but at least familiarize you. So what is object-oriented programming? So the way this paradigm of programming works is instead of you having functions or scripts where the data in that script can be accessed by whoever using it and can be manipulated by anybody using it, what you want to do is to most of the time hide the interior data, right, the personal data, and protect them from manipulation. So this is called encapsulation of the data. Okay, so you want to keep them safe. You don't want everybody to come and change your data, modify your data, or basically even see your data. Okay, and the other advantage that it has is modularity. When we deal with programming as writing a bunch of objects. What is object? I'll tell you in a second, but the good thing is it allows our program to be modular and to write these reusable object codes, or class actually. And so we can use it anywhere in so many different applications without us needing to change anything. So now, what is an object? Object is a combination of functions and data, to put it simple. Here, instead of data, we call it properties, or sometimes we might call it instance variable. And instead of functions, we call them a method or a behavior. So it's a combination of data and the functions that act on those data. Okay, now the data is encapsulated, it's surrounded by the functions. What does that mean? It means the only way you can access this data, see them, work with them, or anything is through these methods. These methods work as a protective layer. The only way I can access and view or anything, change the data properties, is through the methods. If I have an external function here, right, and I want to use this external function and access the data inside this object and modify or manipulate it, I cannot do that. So my data is encapsulated, is protected. Okay, so that's the idea of an object, combination of data and function. Now, how do we create these objects in MATLAB? So to do that, we have something called a class. What is a class? A class is a blueprint for creating an object, right? For example, is like a human. If you consider this object to be a human, right, then this class could be like your DNA or something, right? That tells you how the cells could be combined to make a person. So a class is like a blueprint. If I have an object that is for a car, let's say, these properties could be, or let's say if this object is an object for a student, then the properties could be like the name of the student, the grades of the student, address, social security number, stuff like that. And these methods could be functions that act on those data. Let's say calculate the average, calculate basically, or find the courses that the student failed in, or find their address, find their birthday, stuff like that. So that's an object, a student. Now class is what? Class is like, as I said, a blueprint. So you say, okay, this is the class student. What's the format of this kind of object? It has 3 types of data, name, grade, and address, and it has 4 functions, methods 1, 2, 3, and 4. Any object that you call student has to have this kind of format, okay? So we say this is the blueprint of the student object, so we call it class student. So now from this blueprint class student, I can initiate or instantiate, if you want, or create, to put it in simple English, different copies, okay? So I'm gonna take this and I say, okay, now I'm gonna go and create object A from it, or student A, you might call it, correct? You might call it student A. Then I can create what? Student B, student C, and so on and so forth. Or if you look at it in terms of a factory, this is like the original mold that you have, and then any copy that you create and send out, it is going to be one of these students, okay? So this is like the mold, this is like the blueprint. We call it a class. So whenever we want to create objects, we need to create what? A class. How do we create a class? We'll talk about it. It has several components that we need to talk about, and we are going to talk about right now. So hopefully the idea is clear. Good. Now, so you see, it specifies the number and types of properties and methods. Good. Now, each object that is created from a class can have its own copies of data, but they all share the same method. What does that mean? It means whenever I create this student A, student B, C, all from this class student, it doesn't mean they all share the same name, the same grade, the same address. Of course, they are different students, so they all have their own names, grade, and address. So they have their own data, but the type of function that they have to act on those data, they are all the same. Good. Now, the methods that you have, there are 2 types of methods in a class, 2 categories. Category 1, we call it instance method. What is that? These are the methods that can access and change your data within the objects. So this is what we initially talked about, that these methods can what? All access this data, they can see them, they can change them, and so on and so forth. If we have those kinds of methods, we call them what? We call them an instance method. There is another category of methods, we call them static method. What are they? They do not access your instance variables. They do not. So then what's the use of them? If they cannot access these properties, what's the use of them? Typically, they are utility functions, utility methods, and they can be used without even creating an object. What does that mean? Means, let's say here, I have another method. Let's see if I can clean up stuff without, there we go. So I have another method here, like this, And this method is not having any contact with the property. So this is an instance method. This is the static method. This static method does not have any contact with this property. So what's the point of it? The point is, I'll show you, when we want to use these objects, let's say if I want to go ahead and change something about the name of the student, right? And let's say method 1 is the one that can change the name. So the way that I call this method 1 to change the name, I use what we call the access operator or the dot operator, which I mentioned. Let's see, where is that? Here. So it is the access operator or the dot operator that you had the same thing in structures. If you remember, in structure arrays, you had the same thing. So if I want to do that, I say, hey, student A dot method 1, whatever the name of it is, and then with that method 1 I pass some name, and let's say some new name, correct? So this is like old name and new name, or maybe I just pass to name and it replaces whatever it is with this name. Okay? So this is how I can access the data. I access it through this method. But if I want to use this guy here, let's say I call it method 5, this static method. If I want to access this method 5, I do not even need to say, hey, student A dot method 5. No, I do not need that. All I need is to name the class of the student, whatever it is, and then dot the method. So without me even creating a replicate of this blueprint and call it an object, and then through that object I access the data, to use this function method 1, I can directly use this method 5 to do some calculations for me, not on the properties, on something general that is not a part of this property. So I just pass to it some data other than the properties and say, hey, method 5 under class student, could you please do this operation for me? Okay, so these are general utility functions. They do not need us to create an object in order to use those to do something. Okay, I'll show you in an example. So no worries if it's a little bit hard to understand, I'll show you. So before I move any further, first question is, how do I create a class or an object? Well, to create a class, we need the keyword in MATLAB called class def or definition. So you start with the keyword class def, and then you provide the name of the class. So here I have a code, and this code is doing some operations on some vectors. So I call it test vector. You can call it whatever you want. Then when you define your class def and then provide the name, and here there are some extra stuff, we'll talk about it later. When you do that, now you have to provide what? The format and the number of properties, and then what? The format and the name of the functions, right? So first you start with properties. You say, hey, properties or data of this class text cover are two data, X and Y, and then end. So pay attention, whenever you start the block properties, you have to also end it. And then the good thing is here you can provide the type of access to this data. Hey, can everybody see that? Can everybody do something to it or no? So this access here, we'll talk about it, it's called attributes. It can be public, it can be private, and other types that we are going to discuss. But here you provide the properties or attributes, not properties, attributes for properties and attributes for the methods. So first you start the properties, you define the type of data that it can have, you end the properties block, then you start what? The methods block. You say, okay, now I want to tell you what functions I'm going to have. Function number 1, I call it test vector A and B. What is that? I pass to it value A and value B, and I want this function to take them and plug them in place of what? X and Y, right? And this type of function that you pass to it your data and it creates the object for you. So this is the one that creates, instantiate an object for you. This function here is what we call the constructor. Okay, let me use a different color. So this is your constructor component of a class, and that's what you see. The first component of a class, other than of course properties and methods that we discussed, is a constructor or constructors. The constructor, first of all, if you look at the constructor function, it has the same name as the name of the class. So the name of the class is test vector. If you look, the name of this constructor is also what? Test vector. Okay, it has the same name, and it should be able to handle the cases where the user does not provide you with sufficient data. So whenever I want to create an object of type test vector, I need to call the test vector function, this constructor function, and pass to it 2 pieces of data, A and B. So something like this. So this is the M file in which I am creating my class, and you can see that, and this is my constructor block. So this is exactly what you see in the Microsoft OneNote. And now that I define my construction function, in order to create an object from this class, I simply say, hey, what? V equals test vector of 2 and 3. So I call it, pass to it 2 and 3, and I expect it to give me an object of this class test vector where X of it is 2 and Y of it is 3. But what if the user does not provide the data for me? Just call this test vector without any input like this here. You see, I do not even provide any data. What should your code do? Should it throw a tantrum and say, hey, I don't like it. Why didn't you pay attention? Why are you doing this? Why are you not providing data? I gonna crash, right? I gonna give you an error and I gonna crash. No. Instead, you think of it ahead of time and you say, well, if the number of input arguments is less than 2, then you initialize the components X and Y to be what? 0. And you see here, in order for me to access the X data of this object V or Y data of that, I'm using what? I'm using the dot operator or the access operator. And nargin is the number of input arguments, right? Please watch my video on number of inputs arguments, output arguments, and variable number of input and output arguments. nargin, nargout, and variable varargin and varargout. These are 4 very useful commands in functions. You can see them in my videos under playlist MATLAB. So you say if they don't provide, you set them to 0. Even if they call it with 1 input, I don't need 1 input, set them both to 0. Else, if they did a good job and did 2 exactly, then what do? I say v.x is A, v.y is y. This is AND for the if, this is AND for the constructor function. So this function will generate a replicate, an object for you, okay? So we talked about constructor. Now there is another thing, we'll talk about it later, called Destructor, but let's continue to the rest of the methods. So constructor is one of the methods really. But there is more here. There is another function that gives you the length of the vector. Once you have the length, once you have x and y component, you can use the square root formula and calculate it. Now, here there is another interesting thing. So the name of this does not, of course, have to be the same as the class type. Good. So I call this length. I call this guy length. And what should be the input to this length? It should be an object, correct? You have to pass an object to it, obj. You have to pass an object to it, and it gives you back the length of that object, which has data x and data y. In here, any object is what? It is simply a vector, a 2D vector, right? So your objects here are simply what? 2D vectors. And in order if I want to refer to this object, whatever object that is passed to it, instead of saying obj, one thing that MATLAB suggests is use the word this. So this here means this object. Okay, first of all, you know this length function is not going to work on any other type of object. The only object it works on is the object it belongs to, correct? So you say, when somebody is saying what's the length of the object that you are a method of, what's the length of this object that you belong to, what would you do? You get this dot x, you get the x data of this vector, square it, you get this data y and square it, add them together and take the square root and return it as the result. So this means this object that you belong to. Okay, so this is another thing that I mentioned for you. Whenever you want to talk about the current object passed in the first argument, and you should always pass it as the first argument, use the word this. So you might have more than one input argument to your function. The one that means the current one, the current object, you always call it this. And you can see that in the next function. This next function does what for you? It adds two 2D vectors, two 2D objects together. How? You have the current vector, and it can receive another vector, another object, and it adds them together and returns the result as what? Object, a new object. So, how does it do it? First, it starts the output as 0 and 0. You see here, I'm calling my constructor with no input. So it started as what? 0 and 0. Then I say the x data of the output is the x data of the current vector plus the x data of the second vector passed to me. The same thing for the y data, and then return it. Okay, if I do not start it like this, it might not be happy, or actually it's better to do it by initializing it. Okay, so again, if you have more than one object, the first one that refers to the current object, you use the word this. The rest of them you can use obj or anything like that. The name doesn't really matter. So this is another method, and then one of the methods that is not always mandatory for most of the simple classes and objects is called Destructor. Since the class that we are writing is a very simple class and it does not really destroying the objects to release the resources that these objects are taking, the memory mostly, and it's a little bit more advanced topic. I just mention it here, but I'm not going to go into the detail of that. So you see, it is a method added at the bottom of the method. It's always the last method that you add. The name of this function is called delete. The argument you pass to it is this, which is the current, basically, object. and you write here whatever you want to write, whatever command. So here I have not really done anything. I'm just displaying, hey, the object is deleted. When you call this on an object, okay, it will release the resources of the object, eliminates the object, make it an invalid object basically. It does not mean it cleans that object in the workspace. It does not clean the handle of the object in the workspace. You have to use the command clear in the workspace to get rid of it. But again, I just mentioned it. I don't want to get into detail of that because that opens another can of worm, which is the handle, class handle, and I don't want to get there right now. I'm just trying to give you an intro to object-oriented programming. If I want to get into depth of this, it takes several sessions, several videos, and this is right now not exactly what I want to do. So just telling you that's another kind of method, that's another type of function that you write for more complicated classes, for the ones that are taking a lot of computer memory and resources whenever you create an object from them. In this case, it's very easy, so I'm not going to get into a ton of depth of that. Okay, so now let's stop here and go to the code, and I demonstrate the code for you. Okay, and then we can also talk about this static method later, but for until this point, let's talk about what we have. So here I have two M files. One of them is this M file that is defining my class. This is exactly the same thing that you saw over here. And then I have a test M file which creates objects, manipulates objects, and do some stuff, uses the methods of them and so on. So if you look at them here in the current directory, you see that the appearance of them is different. So if an M file is a script or an M file is defining a class, if you look, the appearance of these files are different. So that's an indication when you see that kind of cube over there that is a class. And when you create an object, let me run this again from scratch. So first let me clean it up. If I create an object using this test vector class and I say w equals test vector like this, it creates an object called w for me. You see it initiated the values at 0 and 0. Why? Because I'm using this case here, that I did not pass any argument to it, so it assumed that they are 0 and 0. In the two other cases that you see here in line 4 and 5, I'm passing numbers, so it takes them and apply to v and z. So look here, when I run it, right, you see your z takes values 4 and 5 for x and y, and v takes what? 2 and 3 for x and y, but small w was 0 and 0. And if you look again here at the variables that are an object, their appearance is different than a regular matrix. For example, if I have a regular matrix, call it W, but capital W, you know MATLAB is case sensitive, and I created, you see now this small w and the large W, capital W are different. This is a matrix. That's the appearance of a matrix. This is what? An object. So whenever you see the blue cube, that's an object. Okay, so this is to use the constructor with or without inputs and create three different objects, W, V, and Z. Good? Fine. Now, there are three types of functions that are very useful for getting information about an object. First, when I call an object with the function class, it tells me which class that function belongs to. So you see, this belongs to the class test vector, V. What kind of data, what kind of properties does it have? It says it's x and y. And what kind of functions would you see in it? It says there are 4 instance functions, add, delete, length, and test vector. This is the destructor, this is the constructor, this one and this one are what? The ones that we use down here to get the length of a vector or add two vectors together. And there is also a static method that I'm going to talk about in a second. But you see, these guys are giving us some useful info. Now, if you type in length in MATLAB help, right, say length, you see there is a function in MATLAB, there is a built-in function in MATLAB called length actually. Okay, and we know that, right? I guess I mentioned it in the first video. Common useful MATLAB functions. This is the command that you run on a vector, correct? So if I have, let's say, a test vector t, and this is equal to 2, 4, 0, 6, negative 9, etc. If I say, what is the length of t, it tells me how many entries it has, so it's 6. So is there any problem here that this function being used in this class is also called length? Remember when in my video about user-defined functions, one of the first things I told you is make sure the name of a function that you create, the name of a user-defined function that you create, does not exactly match the name of any built-in function of MATLAB. But here, this one does, exactly. Now, is this length and that built-in length, do they cause any problem for each other? Is there going to be any trouble? No, because I'm using this function, this method within this class. So it only works, this function, when the data you are passing to it is an object of class test vector. Otherwise, this guy is never going to be used. Which length is going to be used? This one. That takes an array and returns the number of entries in it. So these functions, they are smart, okay? The built-in one or the one that you have. When they get a piece of data, they look at what class, what kind of data it is, and then you'll see they act, okay? So as long as you have a function, even with the same name as built-in functions, but they are defined within a class, there is no problem, okay? Don't worry about that. Okay, so let's say, for example, I say, fine, could you give me the length of v dot length? And this is sure, it is 3.6. And if you look at v, well, if it was the regular command length and v was an array, it would say length is 2 because it has two pieces of data, 2 and 3. But now it is giving me the magnitude, correct? It is giving me really the norm of this vector, right? So it is, that number is square root of what? 2 squared plus 3 squared, 3.6, and this is this number that you see here. So it is working fine. By the way, I do not need to pass any inputs to it. Why? Because it does act on v, right? If you remember here, we say what? We say length of this. So whatever object is calling it, it takes that object as the input and give you the length. So when I say v dot length, it takes this v and then plug it here, really. That's what it does. Okay, now, what's the x data of v? You can simply use the dot operator that I mentioned, and you see here all over the place. What's the x data of v? It says it's 2, fine. What's the y data of z? That's 5, fine. Could you change the x data of v, which was 2? Could you now change it to 6? Sure, I can. Now look at v. Now it is 6 and 3 instead of 2 and 3. Okay? So if you want to access or modify them, you can do it using the dot operator. Now, could you add to v the z object. Now here your v is 6 and 3 and your z is what? 4 and 5. So when you add 4 and 5 to 6 and 3, you should get 10 and 8. So let's do it. Here we go. Now y is going to be what? 10 and 8. Again, it takes z, but it knows the first argument of the function add is v itself, because you said what? You said add this, add your calling object to the object I'm passing to you, and return the result. Okay, so although here you don't see two inputs, there are two inputs. The first one is the calling object itself, the object that is using this method. And finally, delete. Now, again, pay attention. When I run this delete here, it shows the message that is inside this delete. Does it mean that the handle for y is gone? No, it is still in the workspace. So if I want to get rid of that handle, I should say clear y, okay? This is just to free the resources, the memory. It does not mean that the object variable or the handle here is cleaned up. Okay, so these are about the instance methods. Now about this static method. First of all, when you want to create a static method, you create a new block. You see here the block of methods is over. I indicate that by this word end. Just like properties that finished over here. Now this method also what? Ends right there. So the static functions are going to be a separate block. You see, they start here and they end here. They are a separate block. How do you define that these are static? Those functions above were not. You use the keyword static here. So before you define any attributes, or if you ever define any attributes, before that you have to tell MATLAB, hey, these are static methods. And then you create any function, you end it, and that's how you define a static function. So here the static function I have is just taking the absolute value of an input and returning it as output. Now if I want to use this static function fixVal, how can I use it? Take a look here. When I want to use this fixVal, do I need to create an object like z, v, w, y, and so on, and then use the dot operator, the name of the method fixVal, and then pass some data to it? No. All I do, I provide what? The name of the class dot the static method. So here, in order for me to use this, I have not created any variable. I just say, hey, method fixVal from class test vector, could you get -2 and return the output to me? It says, sure. The output is what? +2, which is absolute value of -2. So see, I called the static method without needing to create any object of that class. That's the difference between a static method and an instance method, the use of which is only depending on creating a vector. So these guys are called instantiate. These three lines are instantiating, creating a vector. Looking at the information about the vector, looking at the properties and changing the properties, running what? The instance functions of the object, and then running the static method of the class, basically. Okay, so these are these important topics I mentioned for you, and let's see what else we need to talk about. So a couple of things. One is attributes, the other one is superclass. superclass and subclass. So first, let's talk about the attributes. What is attributes? Attributes are these parts of the code that we have used, and now we want to explain that the access of the properties is public, the access of the methods is public, or this static function method is public. What does that mean? So to show you a difference, I want to do something and then I'll go over all different types. So here you see the properties were access public. So when I say, hey, V, what's your properties? It says X of me is 6, Y of me is 3, right? Now, if I go ahead and change this to private, okay, access to the data is private. Now, let's do it again. And we just go up to here. So we're going to stop at line 10. Just go to the first 9 lines. Look. Line 9, say, hey, X, what's the data of you? I'm sorry. I'm going to throw an error at you. I'm not going to give it to you. My X is not a public property I can show you. I'm sorry. Even when you above here in line 7, you say, hey, what are the properties of V? It says no properties. Although there are properties, there are data X and Y, I know them. But when I say V.X, I'm sorry, I'm not going to show you. I'm not going to even tell you there are data inside V. But can I, let's say, do something with that X data in V? Sure. Like what? Well, when I run this command length, the command length needs to know what? The command length needs to know the X data, right? So when I say what is v.length, you see it's still working. So this function length can see and can access the X data, the X property of V. Can I see it? Can I see what even types of properties this guy has? Absolutely not, because I made my data private. So now they are hidden, they are encapsulated. That's the difference between a public and a private access. So let's look at different types of attributes that we have. For properties, one of the important types of attributes you have is access, which we just showed you. If the access is public, then it means this property can be read and written from any part of the program. If they are private, they could only be accessed by the methods of that class or that object. And if they are protected, then they can only be what? Read and written by methods within the current class or one of its subclasses. So here is the time to talk a little bit very briefly about subclass and superclass. So let me go up. So classes in general could be of two categories, a superclass and a subclass. Superclass is like a parent, subclass is like a child. So your superclass is going to pass its DNAs to the subclasses. So whatever properties it has, whatever methods it has, it's going to pass them all to these children. So these are subs. This is the super. So they will, what we call, inherit the variables and the methods of the superclass. Okay, so this word inherit is an important word here. They get the same type of data and function from the superclass, but they can also have their own variables and classes too. So this guy can have also some other classes, and it can have, let's say, some other data types. So if I show blue for data and red for function, each one of them can have their own type of what? Data and their own types of functions. They do not need to all even look the same. Each subclass is a class of its own, right? It's just like the children. They have the DNAs of mom and dad, but there are some mutations as well, and there are some differences as well, right? And these siblings, they have their own mutations, each one. So that's exactly what we have. And typically that means your subclasses are typically larger than the superclass because they can have additional data or additional functions. Not only that, they can override the methods of their superclass. So if there is a method here that does something and the subclass inherited that, it can have other methods that say, hey, although my dad was doing this every morning, now I think it's not a good idea. I'm going to do something else. If my superclass did this operation on this data, now I might do a little bit differently. Okay, so they can overwrite. So subclasses, they have more capabilities. They are larger. They are more complicated. And this is the idea of superclass and subclass. Now, how do I show that in definition of a class, whether it's a subclass or a superclass? What I do here is this portion that you see, less than superclass name. So if a class is a subclass, I need to provide also the name of its superclass. I need to say who is his mom or dad. And that's what you can see here. And all you need is something like this. You say, hey, this class test vector is a subclass of, let's say what? Just vector or my vector. So I have a class called my vector. It's a superclass, and this test vector belongs to that superclass. It's a subclass of that. So the symbol less than here means it belongs to. Okay, so here I commented it because I do not really have a superclass for this test vector, but if I did and this inherited this stuff from that, I have to use this kind of symbol. So whenever you see this, you know what it means. Good. So now going back, this protected means this property can only be what? Read and written by methods of the current class and the subclasses, right? So if I have, going back to that definition, if I have some data here, it can only be accessed by what? By the methods within that superclass, as well as what? The methods of the subclasses. If these guys can all access it as well as this major guy, then we call that property what? Protected. If it's only this green one, only the method of that superclass can access it, we call it private. And if everybody from everywhere can come and say, hey, I want to see what's inside, I want to change it, now it's public. Okay, so hopefully the idea of public, private, and protected are clear. Good. Let's go back. So I guess I mentioned access of public, private, and protected. That's one of the attributes of a data in a class or object. There are other things too, and it's get access, set access, hidden, constant, and so on. Like for example, when you say hidden, the default is false. If true, the properties will not be displayed in the property list. So maybe here, look, remember anytime here wanted to say, hey, what is v of x, or what is property of x, it throw an error at me, right? Look here at line 7, remember? Because the property was private, anytime I was asking for it, right, I got an error here, right? Here I didn't get an error for asking for properties, but here when I say, okay, could you show me the x data? Now it is not going to be happy. It gives you the error. So the command properties handles private data, but when you're trying to access it, see it, forget it. I'm going to give you an error, right? Now, what if I go ahead and instead of private say, hey, this, I want it to be what? I want it to be public, but I want it to be hidden, correct? Right? So I wanted it to be hidden, and I still want it to be access public. Of course, you have to start it with capital H, correct? Now what's going to happen? Here. Okay. Here, is it going all the way to end? Yeah. Let me just stop it at line 10. Here we go. So when I said what is property of V, correct? Here, let me do it separately. What's property of V? It says there is no property. There is, but it's not showing to me because I say it's hidden. When I say what is V of X, actually it gives it to me. You see, that's the difference between hidden and private. Private does not give it to you. Hidden hides it, try to hide it if you call the command property and list the properties, but if you use the dot operator, you know the name of it, you know the name of this data is X, then you can access it, right? You can see it, access it. So really hidden is just data hiding, not limiting the access. Okay, so that's the difference. And then there are other things too, like constant, for example. When I say a property is constant, by logically it's false, default is false, but if I say true, then they are constant defined once. So they are going to be dealt with as constants. The functions cannot come and change them. They are constants, okay? If I get another class or another object, they all inherit this data, but as a constant, not as a variable, okay? So if I go ahead here and say these data are constant, correct? Right? So save it, start again, and let's just create V. So here we go. You see, I said, what is the test vector on 2 and 3? Boom, it gives you an error. It says, hey, you cannot set the value. Why? Because they are constant. So if they are constant, you better what? You better provide some numbers for them, like 4 and 5. And then here in your constructor, you better not ask for anything. Because in your constructor, you are trying to assign the numbers to them. But if they are constant and nobody is allowed to change them by calling the constructor, so the constructor is not really a good idea to assign anything, okay? So once you just call it, it just better create something called V, and that's it. You should not really do anything. So you have to be careful about the properties that are constant. Okay, so you cannot really use the constructor the way you do. You cannot change them or do anything to them. And we have, of course, get access and set access. Get access, it could be public, protected, or private, as we talked about. And what does that mean? Get access means this property can be read and written from any part of the program. Private means only by the methods within the current class. Protected means only what? By the methods of this class or the subclasses. And a very similar thing happens for set access, right? Correct? So this property controls the write access, the top one controls the read access. The access controls both of them, really. So if you want to know what's the difference between access, get access, and set access, set is to change that property, to write, to change the value of it. Get is only to read it. And access is both of them together. So when you say access private means both get and set, they are both private. But if you want to let them see it but not change it, you can say get access is public, but set access is what? Is private or protected. Okay, so it's up to you how you want to allow the user to interact with your objects. Correct? Be able to see it, be able to change it, be able to only interact with it through the methods and not see and not change. Okay, so these are important properties of the data, and we have something similar for the functions. Again, we have access for the functions, public, private, protected. We have hidden, very similar. We have static, that I guess I mentioned to you. They do not depend on the object and they can directly be used by the name of the class I mentioned. There is another attribute of the methods, is called sealed. Sealed means it cannot be redefined in a subclass. Okay? So in the superclass, you might be able to redefine it, but once a subclass inherits that, the subclass cannot override it. It cannot redefine it, really. Okay, so these are some important attributes and the notion of superclass and subclass. Now, have I explained everything you need to know about creating classes and object-oriented programming? Absolutely not. I just, again, touch the idea, but I guess this is enough for you if you want to do some basic tasks in MATLAB using object-oriented programming, and specifically for my next video on App Designer. They should give you a good start up to get your job done over there. So stay tuned for my next video on App Designer. And if you want, I can provide you with some good text on the rest of the topics on object-oriented programming. There are so many things, handles, listeners, so many things. And overloading of methods and so on. But again, let's just keep it at this level for the moment being. Thank you so much for your attention. I will see you in my next video.